Well, not really by Titans, but hello and welcome. We're going to look at section 8.6 tonight. That is linears, exponentials, and quadratics. Oh my. Linears, exponentials, quadratics. Oh my. So if you could, please open up those journals, page 272. Had a lot of requests for more Bieber after the last video, but unfortunately he wanted a lot of money, so we went with a little old school in sync tonight. Here we go. Let's look at a definition first. The average rate of change. Turns out the average rate of change, we talked about this before. Back with lines, it was the slope. And to find the slope, we just did the change of y over the change of x. Change of y over change of x. And you'll see me use this later as delta y, change of y, over delta x. Just little triangles. Okay, so quick definition. We'll come back to that later on. But let's see what else we've got here. First core concept on the screen there in your journal is linears, quadratics, and exponentials. All graphs we've looked at before. You'll notice a line, just a straight line. An exponential gets really big really fast, and a quadratic is a U. All the ones we looked at. So how do we know what's what? Well, let's look at a few examples first for your notes. Which one's which? So, which one is it? That's the question. Let's see here. Here's part A. Question A. I'm going to give you a bunch of points. First one's got points 4, 4, 2, 0, 0, 2, 1, negative 1 half, and then one more point, negative 2, 4. So I've got these points. How do I know which one of those three functions it is? Well, let's just go ahead and graph these. So let's just draw a little graph right over to the side here, and I'll put some marks in here. Alright, we got that on there. Now let's go ahead and graph that first one. So let's graph it on there. We got the point 4, 4, so right about here, 2, 0, 0, 0, 0, 2, 0. Oh, that should be 0, 0. Sorry, I apologize. That third point there should be 0, 0. 1, negative 1 half. Otherwise, we get a bad one. 1, negative 1 half. And negative 2, 4. Alright, let's look at that. Ooh, what does that happen if we connect those? It actually makes a U. So just using a graph there, we found out that that first one is a quadratic. Alright, let's look at another one here. Here we go, part B. Part B, we got the points 0, 1, 2, 4, 4, 7, negative 2, negative 2, and negative 4, negative 5. Alright, let's go ahead and graph those points. 0, 1, 2, 4, right there. 4, 7, right there. Negative 2, negative 2. And negative 4, negative 5. Oh, what does it that look like if we connect those? Now, if I had a perfect graph paper, it's actually a line. So this one would be linear. So based on our graph, we know that that one's a linear. Let's do one more. Part C. What if we have these points? 0, 2, 2, 8. That's an 8. There we go. 2, 8. 1, 4, negative 1, 1, and negative 2, 1 half. Well, let's graph them. 0, 2, right about there. 1, 4, right about here. Skipped one. Gotta do 2, 8, 2, 8, and be way up here. Negative 1, 1, and negative 2, 1 half. Ooh, yep. What happens if I connect those? That is exponential. As you can see right here, that one is exponential. So the first way we'll learn how to figure out which one it is just by graphing. And we've graphed all these in the past. We can tell what they are. Second way, if we scroll down or just look down the page, is looking at the differences and ratios of functions. And basically what we have here is we have linear functions, which the first differences are constant, something we've done before. Keyword there is first difference. Exponential functions, when we have a common ratio, so that means we multiply. On the first one we add or subtract. And for a quadratic, we're actually going to look at the second differences. So let's look at a few examples. Again, our topic here is which one is it? This time we're given an XY chart. So let's make a little XY chart for the first one here, A. So A, on our XY chart, we're going to have -3, -2, -1, 0, and 1. And for Y, we're going to have 11, 8, 5, 2, and -1. Remember, those are points. -3, 11. Another point would be -2, 8. So now let's, oh my goodness, I just deleted that. How do I bring that back up? Yikes. I cannot. There we go. I'll make that XY chart again. Sorry about that. XY, -3, -2, -1, 0, and 1. Y, 11, 8, 5, 2, and -1. Okay, now we got that. Now we're going to look at the differences. So what do we do from -3 to -2? We add 1. -2 to -1, we add 1. -1 to 0, we add 1. 0 to 1, we add 1. What about with these? What do we do? From 1 to, or sorry, that was 11, wasn't it? That first one should be 11. From 11 to 8, we subtract 3. 8 to 5, we subtract 3. 5 to 2, we subtract 3. 2 to -1, subtract 3. Notice those are the same. That would be the first difference, all the same, so that means this one is linear. Linear. Let's do another one now. Let's look at B, example B. We're going to make another XY chart. Here's the x's you're given. -2, -1, 0, 1, and 2. Here's the y's. 1, 2, 4, 8, and 16. Well, let's look at those first differences. Up top, we're adding 1 again. It's the same numbers as the last one. Add 1 each time. What are we doing on the bottom? Well, you'll notice the first two numbers we'd add 1, the second ones we'd add 2. Those aren't the same. So then we'll look to see if we multiply. And we multiply the first one by 2. 2 times 2 is 4. 4 times 2 is 8. Oops, I made that. That should be a 2 there. 4 times 8 is 2. 8 times 16 is 2. 8 times 2 is 16. So we multiply by 2 on each of those. And since we multiply, we know we have a common ratio, which means it is exponential. So the answer for the part B there is exponential. Then let's look at one more here, C. How do we figure this one out? Alright, let's make an XY chart. Boom, boom. I'll just write that right up here. X values, once again, -2, -1, 0, 1, and 2. Nothing changed. But for the Y values, we have -1, -2, -1, 2, and 7. So again, we know since the top ones are the same, we add 1 each time. No big deal. But if we look at the bottoms, we don't add the same number each time. The first time we add 1, then we actually subtract 1, and then we add 1, then we add 3 to go from -1 to 2, and to go from 2 to 7, we add 5, so we're adding a different number. So we look to see, can we multiply? No, we can't take the same number and multiply each time. So what we do here is we look at the second difference, and the second difference would be between these two numbers. So from -1 to 1, we add 3. From we add 2. We add 2. From 1 to 3, we also add 2. From 3 to 5, we add 2. So each time there, we're adding 2. Those are the same. These are what we call the second difference. These are what we call the first difference. Since the second differences are the same, that means it is quadratic. Quadratic. Second differences. So we got to go down one more level. Alright, we got one more little section here to talk about. We're looking at comparing functions using average rates. And when we talked about comparing functions using average rates, we're looking at the same interval here, the same interval, and over the same interval, the average rate of change for a quadratic is a lot more than lines. So quadratics increase more than lines. And then exponents, or exponential functions, increase a lot more than lines or quadratics. And we saw that in the graph. That one got a lot bigger, a lot faster. So in order to do this, we're actually going to need a couple examples here with some graphs. So I'm going to go ahead and drag those over here. And let's take a look at a couple examples when you do this. So now we're looking at these two charts, which are talking about two social media websites which are opening their memberships to the public. In part A, we've got a chart, and in part B, for website B, we've got a graph. What we want to do is part A of this question asks us to predict the rate, or actually calculate the average rate of change from day 10 to day 20. So for what we'll do is we'll look at day 10 to day 20 here. So part A for website A, we actually have like the points 10, 1400 and 20, 2150. And if we remember, when we calculate the rate of change, we change of y over change of x. So we would go ahead and take 2150 minus 1400 and divide that by 20 minus 10. Change of y minus change of x, which gives us 750 over 10, which is 75. And then let's go ahead and look at B. Well, B, we're actually going to have to look at the graph. So on the graph, it looks like it's about 10, 850, and 20, 1800 are my points. So again, I've got my 2 points, 10 and 20. Let's go ahead and look. Change of y, 1800 minus 850 over change of x, 20 minus 10. And those numbers give us 950 divided by 10, which is 95. So which one's bigger? Website B. So basically what we'd say is, for part A, we would say that website B increases faster. Increases faster. And then question B says, predict which website will have more members after 50 days. Well, if we look at the end here, we see that at day 25, this one's at about 2400. This one is at 25, so they're about the same, but which one increases more? Website B increases a lot faster. So I would say, which website will have more members? B, because it is increasing faster. Alright, so there's our few examples. We learned how to check to see whether it's a quadratic, linear, or exponential based on a graph, based on a chart, and then we looked at a little bit of data here. What I'd like you to do, please, if you could look at your journal, go ahead and go to page 273, you're probably already on it, and see if you can do numbers 1, 3, and 5. Remember, we are truly better together, Titans. Have a great day, evening, whatever you've got left. We will see you in class. Later. Bye, bye, bye.